Isaac Newton went home to Lincolnshire, and there he'd commence a process of discovery which was to guarantee his scientific fame forever.
This period, spent at home at Woolsthorpe, was to mark the beginning of what was to become known as Newton's Annus Mirabilis, the Year of Miracles. During this time, he continued his work on optics and even devised the theorem of calculus. But it was his brush with an apple that was to inspire his finest moment. Are you sitting comfortably? Then we'll begin. Whilst the story of Newton's discovery of gravity is almost certainly something he made up to make himself look clever, it has nonetheless entered folklore. Who knows what the young Isaac Newton was really thinking that day as he sat in the orchard at Woolsthorpe Manor? It's possible that science was the last thing on his mind. Whatever the truth, the brilliance of his insight was this. When the apple fell to earth, Newton was suddenly seeing stars. In a flash, he realized the force acting on the apple was the same force that held the heavenly bodies in place. And when he eventually came to, he would devise his famous law of universal gravitation.
The force of gravitational attraction between two objects is in inverse proportion to the square of the distance between their two centers.
Newton expressed his laws in mathematical terms, but essentially he stated that every object exerts an attraction towards every other object, and the heavier the object, the greater that attraction, whereas the closer the object is, the stronger its pull. This discovery was simple but revolutionary, and he published his findings in one great volume.
This is an original copy of Isaac Newton's Principia Mathematica, the mathematical principles of science. This is a pretty formidable volume, nearly 500 pages of detailed mathematics and geometry. You may wonder how long it took him to write it. In fact, it took him little more than 3 years to produce this extraordinary work. So many of the terms that we now take for granted were introduced into scientific parlance for the first time. Action, reaction, inertia, force, and all of them pertained to one great and predictable mathematical law, the law of universal gravitation.
It was universal because it applied to everything. Using it, Newton was the first person to explain why there are 2 tides a day. He realized that the gravitational pull of the moon draws the water on the Earth toward it, causing a mass of water to gather at the point nearest to the moon. Meanwhile, another mass remains at the point furthest from the moon, where its pull is weakest. This means that the sea is deepest at 2 points, where it is closest to and furthest from the moon. Since the Earth rotates every 24 hours, any given point will pass through high water twice and low water twice. Newton also went on to explain how the combined effect of both the sun and the moon produce the spring and neap tides. And there was still more to come.
Using his laws of universal gravitation, it became possible for Newton to predict with an incredible degree of accuracy the movement of the planets.
He realized it was gravity which controls the orbit of the moon around the Earth, in much the same way that a piece of string holds a stone from flying away when it's spun around. What is more, his calculations finally explained why the orbits of the planets are elliptical rather than circular. This is because a planet's momentum leads it to overshoot at the ends of its orbit before gravity brings it back again.
The great beauty of Newton's laws is that they prove to be constant in every part of the universe, from the dropping of a piece of chalk to the movements of the planets themselves.
And what is more, even now these same principles are used every time astronomers plot the motions of the planets or astronauts travel into space.
How about that?
Newton's discovery of the laws of gravity made him famous. However, his work bore key similarities to the published researches of his bitter rival, Robert Hooke. But typically, Newton refused to acknowledge his influence. Moreover, Newton's famous 3 laws of motion also drew heavily on Hooke's work. Let's have a look at them.
Law number 1. Number 1.
The law of inertia basically states that an object at rest tends to stay at rest, unless, that is, an external force is applied to it. Pretty simple, really.
Law number 2. Number 2.
Now then, this is a little more complicated, so pay attention. It deals with force and acceleration. Newton states that the force of a body is equal to its mass multiplied by its acceleration.
Yes.
But basically, what he's saying is that if you apply force to an object, it changes speed and accelerates in the direction of the force. And if you push twice as hard, the acceleration will be twice as great. Whereas if the object is twice as heavy, it will accelerate half as much. Have you got that? Good.
Law number 3. Number 3.
The third and final law is a piece of cake. It states that for every action, there is an equal and opposite reaction. Basically, it explains why the white ball makes the black ball move. And of course, these laws don't just apply to pool balls. They apply to everything.
Yes.
Isn't that brilliant? Although Newton was convinced that his universal laws would apply to planets just as they did to apples, frustratingly, he'd never been able to prove it. But in 1684, he was visited by the young Edmund Halley.
Halley and Newton started to work together on the nature of cometary orbits and the application of Newton's theory of universal gravitation.
Halley realized that if Newton's law of gravitation was correct, there was a particular comet which should return in just over 75 years' time. He made sure the astronomers across the world knew of his prediction, knowing full well both he and Newton would be dead by then.
In 1668, Isaac Newton returned to Cambridge, where he was given the Lucasian Professorship of Mathematics. He started to re-lodge in Trinity College and shared a set of rooms with a chap called Henry Wickens. Now, Henry Wickens later became a major source of Newton mythology.
Trinity College was said to be charmed by the absent-mindedness of its illustrious professor. At mealtimes, Newton would forget to eat, lost as he was in deep scientific thought. Working alone in his room by candlelight until the small hours, another myth suggests Newton invented a cat flap, which he installed in his study door. This story was later embellished, suggesting Newton had actually installed 2 cat flaps, one for the mother cat and a smaller one for the kittens. This may have been a myth, but what isn't a myth is that Newton, the great man of science, also spent 35 years of his life studying alchemy, the mystical forerunner of chemistry. Some scholars have even speculated that his depression in later life may have been caused by chemicals ingested while carrying out these peculiar experiments. His aim was to discover the mysterious secret of matter. But Newton's interest in alchemy was not unusual for his day. Many educated men were fascinated by ancient spirituality, and for Newton, spiritual matters were a key part of his thinking.
Although we think of Sir Isaac Newton as a scientist, we must never forget that he was also a deeply religious man. He was also one of the greatest biblical scholars of the age, concerned with dating things in the Old and the New Testaments. Biblical prophecy was absolutely paramount in his thinking. Isaac Newton never found human relationships easy, and there's no evidence that he ever showed any interest in women. Following the publication of his Principia, however, in 1687, he became internationally famous and came to know many people. One of these was a young, brilliant Swiss mathematician by the name of Fatio de Douillet, and the two formed a rather passionate friendship.
although almost certainly a completely celibate one. But when this fell apart in 1693, Newton was pitched into a deep depression from which he never fully recovered.
During the time that scholars have come to call Newton's Black Year, he sent a collection of rather bizarre letters to his friends, to the famous diarist Samuel Pepys and the great philosopher John Locke. He wrote to Locke, "Why are you trying to embroil me with women?" What on earth was he thinking of?